We're looking at Honors Geometry Section 3.5 on parallel line converses. The converse is when you switch the order of a conditional statement. Before we had some postulates about parallel lines. If two lines are parallel, then the corresponding angles are equal to each other. However, in this one, we're saying if two lines are cut by a transversal so that the corresponding angles are equal, then the lines are parallel to each other. So we're saying if the corresponding angles are equal, then the lines are parallel. So here's our abbreviation for that. In other words, if we know that these two angles are equal to each other, and this is what we're starting with, then we could say that those two lines must be parallel to each other because those corresponding angles are equal. And just like we had more theorems based off of the different pairs of angles we're looking at, we have an alternate exterior angle converse. In other words, if these alternate exterior angles are equal to each other, and I'll call this line L, this is line K, then we could say that line L is parallel to K because of this alternate exterior angles equal means the lines are parallel to each other. We have alternate interior angles converse. So if these alternate interior angles are equal to each other, then we could say that line L is parallel to line K in this case. And one more, and this is maybe the sloppiest one. If we have that angle 1 and angle 2 are supplements of each other based off of their location, then we could say in this case that line L is parallel to line K. Now, we can't just assume these are true. We need to prove that these converses are true using only that initial postulate. So let's see if we can prove the alternate interior angles converse. In other words, let's say we know that angle 3 is equal to angle 4. So this is our given. The measure of angle 3 is equal to measure of angle 4. And I'll write that down over here so it's clear. This was given to us. And our goal then is to prove that line L is parallel to line K. Well, similar to the way that we proved the theorem, I can add another angle in here, maybe angle 5 right there. And now I know that measure of angle 3 is equal to the measure of angle 5 because of the vertical angles. And with the transitive, tying those statements together, we can now say that the measure of angle 4 is equal to the measure of angle 5. And since the measure of angle 4 equals measure of angle 5, we can now say that L is parallel to K. And the reason for that is since corresponding angles are equal, it means the lines are parallel to each other. So there is my argument as to why the alternate interior angles converse work. Let's look at an informal proof. We're given that 3 and 2 are supplements to each other, and we want to make an argument that M is parallel to N. So maybe you want to pause the video at this point and see if you can make this argument on your own. When you're ready, you can look back and listen to the explanation of how I did it. And what I would say is that angle 3 and angle 1 are supplements. And the reason for that is because of linear pair. They're linear pairs with each other. And since angle 3 and angle 2 were supplements and that was given, we know that those angles add up to 180 degrees. That is the definition of what it means to be supplement. Likewise, we can say that the measure of 3 plus the measure of 1 also equals 180 for that same reason. And now, tying these two statements together, since 3 plus 2 equals 180 and angle 3 plus angle 1 equals 180, we could say that the measure of angle 3 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 1. That is the transitive property. Now, if you'll notice, algebraic here, we subtract the angle 3 from both sides, and since angle 3 is equal to itself, we would call that the reflexive property, but we're going to subtract it from the left, subtract it from the right, and that'll give us that the measure of angle 2 is equal to the measure of angle 1, and that was just subtraction using some algebra. And now I notice, okay, look at the location, 2 and 1 are alternate interior angles, so that means to us that M must be parallel to N because those alternate interior angles are equal, the lines are parallel, or I could call it the alternate interior angles converse. And that's what we're trying to prove. Next one, we have a series of lines that are parallel to each other. So L is parallel to M, and T is parallel to M. So maybe for my drawing, I need to be consistent here and say that those lines are parallel to each other. Given that measure of angle 1 equals measure of angle 2, we're trying to show that K is parallel to R. I'm going to have a few steps in this one. These two green lines are parallel. We have a transversal. So if I give this a new name, I could say that the measure of angle 3 is equal to the measure of angle 1. Parallel implies that corresponding angles are equal, or the corresponding angles postulate. And while I'm doing that, I'm seeing that over here, parallel, parallel, and we have a transversal. So let's go ahead and call this angle 4. And for that same reason, we can say the measure of angle 2 is equal to the measure of angle 4. It's that corresponding angles postulate. Now here's the really big step. I'll use the yellow color to illustrate this. Angle 1 is equal to angle 3, or angle 3 equals angle 1. Here is angle 1 equal to angle 2. In our proof, we said angle 2 is equal to angle 4. So I'm traveling through all these equal signs. 3 equals 1, 1 equals 2, 2 equals 4. So tying these things, all three together, we can now say that the measure of angle 3 is equal to the measure of angle 4, and that is our transitive property. Why is that significant? Let me clear up some of these highlighted regions here. Notice, line, line, I'm trying to get those parallel to each other. This serves as a transversal connecting them. And based off of their locations, 3 was equal to 4. That's great. Well, those are alternate exterior angles. So we can now say that this orange line on the left, that is line K, is parallel to this orange line on the right, that is R. And the reason for that is since those alternate exterior angles are equal, the lines are parallel. That's our alternate exterior angles converse. And that's what we're trying to make the argument for. All right, a few algebra examples. It says to solve for each variable so that in order to make the lines parallel to each other. So if these two lines are going to be parallel to each other, I notice that these two angles are consecutive interior angles, which means in order for those lines to be parallel, these would have to be supplements. So we're going to add them up. Take the 13x plus 10 plus the 2x plus 50 and set that equal to 180. So doing some of the algebra, I'm seeing that this is 15x plus 60 equal to 180. Subtract 60 from both sides. So now 15x is equal to 120. Divide both sides by 15, and x is going to be equal to 8. X is 8. I can plug it back in to verify that the top angle and the bottom angle are in fact going to be equal to each other. The bottom one looks like it's going to be 66. I think the top one then is going to be 114. Okay, to the right. I want these lines to be parallel to each other. I'll notice that this angle and this angle are alternate exterior. Alternate exterior angles are supposed to be parallel. So if we set the 5x minus 15 equal to the 2x plus 18, do some algebra, subtract 2x from both sides, add 15 to both sides, divide by 3, and I get x equals 11. Plug it back in. It looks like this one is going to be 40 degrees. Plug it in up there. That's also 40 degrees, so it looks good. This is a different question. It's not saying find x so that the lines are parallel. The question is, are these lines parallel to each other? If they were parallel, these two same side interior angles, or these consecutive interior angles, would have to add up to 180. But since I don't know that the lines are parallel, I don't want to set them equal to 180 because I don't know if it's true. However, what I do know, I know for a fact, is that these two angles form a linear pair. So I know that these two angles must add up to 180. So if we add them up with each other, the 10x minus 30 plus the 3x plus 2, so that gives us 13x minus 28 equal to 180. Add 28 to both sides, so 13x equals 208. And I want to divide both sides by 13. So how many times was 13 going to go to 208? 78, 16 times 3, so that's 78. Looks good. So x equals 16. What I know for sure is that x must be 16 in order to make these two angles supplementary to each other, which must happen. Now here's our next step. Since x equals 16, let's plug it in. 3 times 16 is 48. 48 plus 2 makes this angle 50 degrees. I'll go up to the top, plug 16 in for this angle. 2 times 16 is 32. 32 plus 16 is this 48 degrees for this angle. And what I'm picking up on here is that if this angle were in fact equal to this other angle down here, and they're alternate interior angles, then the lines would be parallel. However, 48 degrees is not equal to 50 degrees, which means the top line is not parallel to the bottom line. So our answer is no. I showed my work. X must be equal to 16. That's true. I get the final answer that no, these lines are not parallel to each other. Next one, kind of a similar problem, and maybe you want to pause at this point to try to figure out what the strategy is going to be, having seen the last one. When you're ready, unpause the video and you can listen to my explanation and see if you're accurate. So, the question, which lines are parallel to each other? Well, I know 95 plus 17z has to add up to 180 degrees because, again, they're a linear pair. So 95, 17z is equal to 180. Subtract 95 from both sides. I believe that's going to be 85. Divide both sides by 17, and so z equals 5. Z equals 5, then yes, this is 85 degrees. I've got my answer for z. But probably even more importantly is noticing that since this angle is 85 degrees, and this angle down here is 85 degrees, since these corresponding angles are equal, use highlighter here, line, transversal. These corresponding angles are equal between those two pink lines. So I know the pink is parallel to pink. Line RS is parallel to line QT. Line RS is parallel to line QT. I know that to be true. So because that's true, I'll look over here on the left side. Parallel, parallel, transversal. So it means these two consecutive interior angles must be supplements. So if we add those together, we'd set it equal to 180. So 3x plus 5 plus 5x plus 7 would give us 8x plus 12 equal to 180. Subtract 12 from both sides, that's 168. Divide both sides by 8, and x is equal to 21. X is equal to 21. Why that is significant is if now I plug that back in, 5 times 21 would be 105. 105 plus 7 means that this angle is going to be 112 degrees. 112 degrees is vertical to the xy, or to the 8y. 112 is equal to 8y. Divide both sides by 8. So taking 112 dividing them by 8. Looks like that's going to be y equals 14. So I have all three variables. I know that, clean this up a little bit. I know that these two lines are parallel to each other. I found that early in the problem. But maybe, just maybe, also true that this line is parallel to this line. So I do want to check that right now. And remember, when we plug this x equals 21, we got this angle down here. I could have plugged it in for the top one. 3 times 21 is 63. 63 plus 5 means that this is 68 degrees. And if I want to see if, in fact, these two lines are parallel, I'll look at this transversal. 68 and 95 are consecutive interior angles. If these blue lines were parallel, the consecutive interior angles would have to be supplementary, but they are not. They don't add up to 180. So the blue lines are not parallel to each other, just those horizontal lines that we found out earlier.